These are the notes for the Go in 2.1. In this Go, you'll be asked to solve one-step equations. Excuse me. Whenever you are asked to solve an equation, you are really being asked the following question. What value or values of the variable make the equation true? So, in order to solve an equation, we're going to need to isolate the variable. And we do this by performing the opposite or inverse operations. So let's look at 3 examples. Our first example, x minus 8 equals 10. We ask ourselves, what operation is happening between x and negative 8? And here I'm subtracting or adding a negative 8. So we say we are subtracting 8. And so the inverse would be to add 8. So I'm going to add 8 to both sides of my equation because I need to keep my equation the same. So I'm just moving one piece over. And then I simplify. Now, since I was asked this question, what values of the variable make the equation true, I actually need to go back and check. So I say 18 minus 8 equals question mark 10. I simplify 18 minus 8, 10 equals 10, and that is true. So now I can truly say that x equals 18. Example 2, 3x equals negative 18. So again, I have to ask myself, what is happening to the x? In this case, the x is being multiplied by 3, and the inverse. Now the inverse, we can talk about it as 2 different ways in this case. We can talk about it as being divided by 3 or as being multiplied by 1/3. So it's important that you understand that these are 2 different ways of saying the same thing, in large part because we're going to continue to push towards not talking about division anymore. So let's actually do this as multiplying both sides by 1/3. On the left-hand side, multiplying 1/3 by 3 cancels, gets me 1, so I have x equals. If I want to do a little bit of extra work here, I could say that negative 18 times 1/3 is negative 18 over 3, and then simplify that to be negative 6. And again, since I was being asked the question, what makes this statement true, I need to double check to see if this actually makes the statement true. So we say 3 times negative 6 equals question mark negative 18. 3 times negative 6 is negative 18 equals negative 18. That is indeed true, so now I can say x equals negative 6. Our third example brings us into a land that's just a little bit more complicated than these first 2. And it is 8/3 x equals 10. So again, I ask myself, what operation is happening between the x and the 8/3, and it's being multiplied. So we are multiplied by 8/3. So I need the inverse. And again, this inverse can be written in 2 ways. It can be written as divided by 8/3. Or it can be written as multiplied by 3/8. Dividing by a number is the same as multiplying by its reciprocal. So I am going to multiply both sides by 3/8. On the left-hand side, multiplying a number by its reciprocal cancels it, so I'm left with x equals. On the right-hand side, I multiply and I get 30 over 8, which reduces, because I can divide both the top and the bottom, by 2 to be 15 over 4. And now I have to do my check. And I'm going to do my check on the side this time so that I can keep it all on one page. So my check here, I have to say, well, is 8/3 times 15/4 equal to 10? Multiplying these fractions, 8 times 15 is 120 over 12, question mark equals 10? And yes, 120 divided by 12 equals 10. So now I can come to my final conclusion, which is to say, yes, indeed, x does equal 15 over 4.